Hello and welcome everyone to the July meeting of Integration Down Under. Let's go ahead and get started. Just through the organizers, Martin, Dan, Renee, Wagner, and myself. And tonight's speaker is Martin Abbott, talking about IoT is also an integration challenge. So without any further ado, I'm going to hand it over to Martin.
So thank you for that intro, Bill. The slide deck is not coming up. There we go. Good. So I toyed with either calling this IoT is also an integration challenge, IoT is an integration problem, IoT is just yet another integration challenge, and I just stuck with this in the end. So so here we go. IoT is also an integration challenge. That's my Twitter handle at the bottom there. And if you haven't been to Perth, then you won't recognise that, but that is in fact the city of Perth as we speak, and that's obviously where I live. So without further ado, let's start moving forward. So who am I? So I'm a Microsoft MVP for Azure. Recently was awarded in June as a Microsoft Regional Director. I think I'm one of 7 or 8 in Australia. I'm an administrator for Global Azure Bootcamp and Global Integration Bootcamp. You just saw I was an admin for this group as well. I had the joy of authoring cloud integration, robust cloud integration with Azure. Although my accent dictates that I probably come from the UK, I'm actually a proud Australian of 5 years now, and a Freo Dockers fan, please don't hate me. And recently, sadly, a widower, a father of 3 boys, and a hater of cancer. Right, so moving forwards. So I thought I'd start with what IoT isn't, because we all kind of think we know what IoT is, I guess, and I thought I'd start with what I think it isn't. So IoT is not a Raspberry Pi, right? It's not a soldering desk, and it's certainly not Arduinos and shields. It's a whole lot more than that. So I thought I'd at least start with what it isn't, because it's not really just about the hardware. So and I think over the years, Internet of Things, it's in the title, hardware and things have become conflated. I think everybody thinks of it as sensors and devices. And when you look at things around the web, you look at Gartner reports and everything else, they all say that they expect there to be 50 billion sensors by 2020 or whatever. So it seems to be always marketed as it's about the sensors. But you know what? Hardware design is hard, and it takes a long time, and it takes even longer to get it into production. Working on a project recently, it took 18 months to get the hardware ready. Now, of course, what you can't do, therefore, is wait for that hardware to be ready before you start doing everything else, because you've got a whole system and solution to build that goes around the outside of that that hardware. So there's many ways around that. You can build simulations, either yourself, writing code yourself, or there's actually a very good IoT solution accelerator, the device simulation solution accelerator. That's what used to be called IoT Suite in the old days. And you can use those sorts of things to help build out your hardware, at least simulate your hardware whilst you're still developing it, and you can move forward. But I think the key thing really is that nobody buys IoT. A business stakeholder doesn't go to the IT department and go, can I have some IoT, please? That just doesn't generally happen. What people buy is an outcome. They buy value. And now that may be delivered through IoT, through sensors and other things, but they're not buying generally an IoT solution off the bat. So what actually is IoT? Well, really it's about the data. And as it says there, devices, gateways, connectivity, data storage engineering, machine learning and artificial intelligence, and some form of action off the back of it. And I think that's a very key point, because that describes what I like to call, and what others like to call, the IoT value chain. So essentially what we've got here is something which starts with things, absolutely, that may be devices and sensors, and ends with some form of intelligent action, whether that's in the form of a very basic static, or at least not static, but slowly changing dashboard that just informs you of information, or whether that's some closed feedback loop that enacts some action back on the device, say to close a valve or something like that. But without these things in place, you don't have an IoT solution. So having the things but no connectivity means you won't get the bits beyond that. And likewise, if you store the data but you don't do anything with it, then you're not really getting any value out of the solution that you're trying to deliver. So it's quite key and important to remember that an IoT solution really has to have all these aspects to it to deliver value to the organization. Now, in terms of the IoT capabilities within Azure, as you can see from this slide, and this slide isn't strictly speaking completely current. There is a lot in the landscape. Starting on the left-hand side, obviously from devices, there's a bunch of stuff that Microsoft already do around things like Azure Sphere, which is very, very secure device hardware, all the way through to intelligent action at the back end, either through something like Power BI if you're doing reporting, bots, machine-to-machine interactions, and things like logic apps for doing workflow integration. And across the bottom there, you can see the pre-configured solutions. So that's what used to be called IoT suites. There's one for remote monitoring, there's one for connected factory, and I've mentioned the one for the device simulation as well. And then at the bottom there, you'll see IoT Central, which is their low-level, almost zero code entry-level SaaS solution for IoT, which works with a bunch of hardware already. So there's quite a lot of stuff there that you can use to help build out your solution. But of course, as I've mentioned, this is really about integration, right? So where does integration fit into this landscape? Well, not surprisingly, we'd be remiss if we didn't think that it fitted everywhere, because you can't do much of this stuff without any form of integration. Key thing about the integration in terms of IoT is everything that you've learned up to this point is still relevant. There is nothing that is very specific to the IoT landscape and IoT solutions that doesn't still fit with everything you've already learned. So all those integration patterns that you've learned over the years, just some called out there specifically, they're still as relevant in the world of IoT as they've always been. So it's not a whole retrain or anything like that. You can use the skills that you already have, and you're still extremely relevant in terms of team membership of an IoT solution. So with regards to with IoT, and in fact with IoT Hub, there's many ways you can do IoT, I suppose, inside Azure. The two main ones are with Event Hub and IoT Hub. Event Hub is just a huge, massive scale ingestion engine. Supports Kafka as well, of course, whereas IoT Hub supports the bidirectional communication that you tend to need in an IoT solution. So just calling out what those are. Telemetry is one way from the device to the cloud. Query is where the device itself may query the backend service for some information. Notification will be when the cloud backend tells the device about something, and a command will be when the cloud tries to get the device or says to the device, you need to do something and tell me when you've done it. So they're the typical communication patterns that you get inside IoT. And not surprisingly, integration plays a part in all four of those. So in terms of IoT Hub itself, so as a central location for where you're storing your device registry and where you're ingesting the data, just thinking about the integration points here, you'll have data coming in device to cloud, that's what the D2C means. So data comes in from your sensors and lands in IoT Hub. That's all kind of handled via the SDKs. If you really, really want to, you can actually just compile the C code if you're running on a device for which an SDK is not available. But there are SDKs available for Java, Python, C#, and of course C, and a bunch of others. So there's plenty of opportunity to build stuff in languages of your choice. There's also an ability to upload files. Now, this is all actually handled directly by IoT Hub. So when you want to upload a file, IoT Hub will give you a location and SAS token and allow you to upload that file, and then there's a confirmation process that allows you to make sure that file has been uploaded successfully. You can use the storage SDK and do it directly if you want, but that then bypasses IoT Hub and you lose that facility by which IoT Hub knows that you've done something. So that's going into IoT Hub, but what about out of IoT Hub? Well, there is message routing. So this should be pretty familiar to most people who do integration. And essentially, it's kind of almost like a publish and subscribe process. So the standard routing endpoints that are supported with IoT Hub right now: storage, event grid, event hub, and service bus. So you can route messages based on filters, and we'll have a look at all this sort of stuff in the demo in a little bit. You route stuff on a basic set of filters. Those filters can look at message properties, or they can look at the contents of the message as well. Now, there's also a thing called time series insights. Now, that's basically just a one one mapping between IoT Hub and into time series insights, and it's essentially a time series type database that allows you to look across your estate of devices and do very quick visual comparisons. You can publish dashboards from it as well for people to see. You can aggregate based over time, based on sums, maximums, and so on, all the usual sort of stuff that you could expect to see in a time series database. And it just does it all for you. It's got a small latency of about a minute instead of real time, but you can look back over many, many days and months. And the last part of that integration story, I suppose, out of IoT Hub is digital twin. Digital twin allows you to have a digital representation of the physical aspects of your solution. So you may have, for instance, a building. That building may have occupancy sensors in rooms on each floor, may have lifts which have maintenance schedules. You can have all of that information landing in the digital twin, which you can then visualize through a bunch of tools. You tend to have to write those yourself, but essentially it allows you to perform roll-ups and aggregations of data and work up through a hierarchy through what they call a spatial intelligence graph, and allows you to build up that hierarchy of information and query it. What you also get out of the back of the digital twin is notification processes. And so you could say, okay, well, if I have an occupancy on a floor and that occupancy is full, I'll take all those room data, those individual room data, roll it up into the floor data, and when the floor is full, I'll send out an alert, as an example. So not surprisingly, off the back of all of those, because those are all pretty standard integration points that we all know and love as integration people, you get to integrate with everything else in the landscape, whether that's through logic apps, through functions, or roll your own, of course, if you really want to. So the key point there really is that whilst we talk about IoT and things, because you've got this thing called IoT Hub in the middle, this essentially landing point for all your data, you have vast opportunity to integrate out of that and into a bunch of other things to do either the data analysis or the ongoing action that you might require as a result of ingesting that data. And then, of course, there's the return path. So once you've got that data and you've done something with it, maybe, again, just as an example, maybe you've got a valve that has a pressure warning and you want to close the valve or open it up if you need to release pressure, you need to send a message back to the device. So that's where the commands or the notifications come in, and you can send data back to the device, because that's the key aspect that makes IoT Hub different to Event Hub. It's bi-directional communication. So there you go. You can see there that IoT Hub is central to a very large portion of integration with an IoT Hub solution. But you remember in that IoT value chain, the middle box was data. And it's a very key point, because when you get your data, you need to store it. You need to potentially do some form of data engineering on it. So, remove fields that aren't important, find your features, prepare your data ready for advanced analytics. And there are a bunch of tools inside Azure that allow you to do that. And again, the reason that I've called these particular ones out is because they also have huge areas that are overlapping for integration services. So we'll just go through these very quickly. So Azure Data Factory, there was a very good presentation previously on Integration Down Under, which I'd urge you to watch. It's on our YouTube channel, so please do find that out. And that will go into this much more detail, but essentially it's ETL in the cloud. So think about it as SSIS, but moved up to the cloud. There's a bunch of functionality built into it. Probably the one that is used by most people is the copy activity, which obviously is just for moving data from one place to another place. It actually supports your on-prem SSIS packages straight away out the box. If you load an integration runtime, which is essentially a data gateway, if you load that on-prem, you can access things directly on-prem. If you run those up in Azure, you can actually load those SSIS packages in Azure, as long as you've got connectivity back onto the on-prem data sources, of course, through a gateway. There's a couple of options for compute, because obviously you can copy, but you may want to do other things as well with data as it's in flight. There's two options really. One is Databricks. probably try and do a Databricks presentation soon. And the other one is Batch, Azure Batch. There's a new feature called Mapping Data Flows, which is in preview currently, and that's kind of very similar to not quite mapping with the functionality that you get in BizTalk. It's not quite that level of mapping, but it is certainly an ability to change data as it flows through the system. And already with Azure Data Factory, there's 80 plus connectors to various other things, be that SQL, be that AWS S3, be that, you name it, and there's stuff there. Not surprisingly, it won't surprise anybody that if there's that many connectors, your mind is probably already thinking, that sounds very much like Logic Apps. Essentially, a Data Factory pipeline is a Logic App under the hood. So one of those other data pipelines is Stream Analytics. So this is for more real-time data processing. Again, inputs tend to be the streaming data sets, so IoT Hub and Event Hub, but also storage. You can use storage to enrich data on the way in as a result of reference data, essentially. And on the way out, there are a bunch of things that Stream Analytics can push to. Azure Functions, Event Hub, storage, Service Bus, Cosmos DB, and SQL DB. And of course, yet again, it won't be any surprise that all of these are integration points that we all know and love, whether that's Event Hub, whether that's Service Bus, whether that's storage, and then using something like Event Grid to fire off an event as a result of data landing in storage. Again, although we're using a data tool, the opportunities for the integration toolkit to be brought out and used to round out this solution is huge. Azure Databricks, so that's essentially a big compute engine in the cloud. As it mentions there, it uses managed Spark clusters. The advantage of using Azure Databricks above other things is that it's got a great security model, and it's also really, really good because you can spin up and spin down clusters just when you need them. So it's essentially almost like a serverless application, not quite, but it's almost like a serverless application. Again, a bunch of stuff that you can integrate into it, streaming data, Kafka or Event Hub. Of course, Event Hub can also stream in Kafka data. Bunch of more static cold path data, so SQL, SQL DB, Cosmos DB, and storage. And then on the way out, very similar to on the way in, you process your data. Now, of course, what this looks very, very heavily like is our old friend, the Lambda architecture. And it is a great tool for combining that real-time data and that more static or cold and older and archived or historian data. And then being able to take action as a result of storing that data somewhere else. And the last one, I won't talk about cognitive services, but the last one that we'll mention will be Cosmos DB. So Cosmos DB has a facility called Change Feed, and that essentially takes, it's almost like a log, which says, or it is a log in fact, so when you insert or update data, something gets written to the change feed, and you can react based to that. So essentially it's a reactive programming model. It's globally distributed, it's very, very low latency, and as a result of the change feed, there are again a bunch of integration points. So again, Apache Spark, so you could run this in a Databricks cluster, of course, Azure Functions, Storm, and that allows you to process information that's in that change feed, and then allows you to put that somewhere else. So obviously, once it's inside Azure Functions, you have a multitude of opportunities to put it in lots of other places. Spark, as you saw from the previous slide with Databricks, can land in a number of places as well. So really and truly, the whole point there really is that through an entire process, whether it's through the ingestion and using message routing, whether it's through once you've routed that data or stored that data somewhere else, being able to process it through a data pipeline, all of that stuff lends very heavily on the Azure Integration Services if you want to round out a full-blown end-to-end solution. So where would you use this? Well, of course, not surprisingly, everywhere you'd normally use standard messaging good practice. Node leveling, streaming data processing, asynchronous messaging. But when you get to the more sort of sharp end of an IoT integration scenario, you may do things like machine-to-machine interaction. So one machine informing another machine that it needs to perform an action. Status updates. So when your battery level is low, maybe you want something to happen, as an example. Firmware updates, so you may have an estate of millions of devices that you don't want to have to send people out, so you want to be able to initiate an over-the-air firmware update to all those devices. Again, integration technologies can solve all these problems. Command and control is the more obvious ones. That's when you may want to send a command to a device to say, do something and tell me when you've done it. But basically the world is your oyster in terms of just what you can dream up in terms in what you can do with the devices once you have that data inbound and you've processed it. So I think tell the story there. Don't want to do that. Right. So here we go. So we'll just go to a quick demo. I think I'm running at about 25 minutes currently, so the demo is about 20 minutes. That's good. So I thought I'd write some code because I don't write code very often nowadays. So top of this, this is just very bog standard. Let me just see if I can make this slightly bigger. No, there we go. Good. Right. So essentially, there's a bunch of boilerplate stuff at the top of this application. So we get a device, we create a string, a connection rather, to IoT Hub. We get the device twin. I'll talk about that when we go to the portal. We got a method that we can call on the device. This is essentially the command and control, which is called reset. We set some desired properties. This is to do with the digital the device twin, which I'll talk about in a little while. And then we set some asynchronous stuff going. So we'll just wander through here and see what this does. First of all, the telemetry. So when this first initializes, we get a bunch of data, which is just our initialized data set. There's a Boolean, which is vary data. That is set by a value on the device twin. So by default, that device twin says that we're not going to vary the data, and it will just send the same data each time. So the purpose behind that is that we can go in, we can change the device twin, and essentially that's sending a notification back to the device to say something's changed, I need you to do something different. So what that will do is that will then start varying the data. And then there's a bunch of tests, and we checked some to see if anything's been breached, if we've gone above our maximum temperatures, and if they have, then we send a different type of message, which is this piece down here. So if there's a different type of alert, we send an alert message, essentially. So we set an outbound bunch of properties. You can probably guess from what this is doing here that we're going to route on these properties so as we can send them to a different endpoint. For the device twin, we have the desired set. So we check to see what the value of a device twin setting is called vary. And we just set that, and you can see here that we're saying vary data is based on that. And if we just quickly scooch back up here, you can see that if we set the vary data to true, we'll start getting varying data out of our device. Reported properties, I thought it'd be useful if we just say sent up a random value for our battery level and a firmware version. So essentially what this is doing is it's setting those reported properties on the device twin, but it's also actually sending that as a telemetry message. And again, we're setting a property so as we can route that message separately. We can also set it to receive messages directly. This is again inbound data, so we can say, okay, we can send a message specifically to the device. This just doesn't do anything other than outputs what it's seeing. As we're collecting the telemetry, we're creating a file, and then on our timer, so this is every 6 minutes. No, it's not 6 minutes, is it? 2 minutes. Every 2 minutes, it will upload a set of data to a storage account that is set by the device or set by IoT Hub, and we can use that. Obviously, we can land large volumes of data. We can compress this as well if we wanted to. It's a fairly typical scenario to collect data, compress it, and send it over the wire, and store it in blob storage, and then have, say, an event grid trigger off of that to say decompress this file and start processing it. Again, pretty typical. And the last bit is here we have a reset device, so we can have a direct method. So that was the two-way communication, the command and control process. We can call this particular method and essentially all we do is we just reset the data when we do that. So, so that's, just go back up here, you can see reset device. We're going to call something called reset device, and that just calls that particular value. So that's the wiring from that end. If we just go back up to IoT Hub, up here, right, so hopefully it hasn't timed out, that hasn't good. So here we are in IoT Hub. We can see here, if we just move down here, we can see a bunch of devices. So I'm only going to use one device today, but obviously this device registry could have millions. So we'll just go device 1. So if you've ever used IoT Hub and you've used the IoT Device Explorer, what you can do in the Device Explorer has now been essentially copied inside the portal. So we can send a message to the device. We can enact or invoke a direct method, which would in our case be the reset device, for instance. And we can play around with the device twin. So if we just go into the device twin here, we can see that vary in the desired properties is currently set to false. And the last time we reported, so last time I ran this, it reported that the battery was 95 and the firmware was 1. The firmware doesn't change, but the battery does. So if we just go back to the devices or go back to the menu here, if we look at file upload, so this is where we go in and we say, okay, well, when I want to do a file upload, I want to set the container and or the storage accounts and the container where I'm uploading it. And then when I invoke the SDK method to upload a file, I'm going to call IoT Hub, I'm going to get a SAS key, and then I'm going to upload through the storage API, and then I'm going to tell IoT Hub that I've finished, so as it can essentially do that positive acknowledgement that things have happened. The last bit of fun here, I suppose, is message routing. So by default, IoT Hub has an event endpoint and an operational monitoring endpoint, both of which you can consume. But if you want to do things that are outside the bounds of just consuming the events or consuming the operational stuff, then you create your own endpoints. So I can come in here and I can create custom endpoints, and we can see if I do add, I can have an event hub, a service bus queue, a service bus topic, or blob storage. So here I've created some queues and blob storage. And then when you want to route to those, you essentially create a very, very simple rule. So for instance, here we can have a look at this rule. And it says, if the message type equals status, I want you to send device telemetry messages to this particular endpoint. And if we just have a quick look at our code, and we go down to the one for status, which is down here, you can see we're setting a message type, status, and we're sending that particular message. So once this message lands in IoT Hub, the routing happens before anything else, and it'll look at that and it'll go, okay, here's message type for status, and I'm going to route that to that particular endpoint. Of course, once it's at that endpoint, it's again in the realms of where we would always like to be in terms of our integration space. So status here is service bus queue, and we can process and manage that as we would normally do. So how do we go around doing some of this stuff then? Well, what we'll do first is we'll, I think, go in here. So using status as a good example, I've got a pretty simple logic app here. If we just edit that. Coming in again. So we'll read it from our status queue. You can see that runs every minute. I'm going to parse it because I like making my life a little bit easier. And then what we do with this particular one is we write that document to a particular collection inside Cosmos DB. So we just create our document, and every time a message lands in that service bus queue, we output it to that particular location. Pretty straightforward stuff. There are a bunch of other logic apps here that I created just for the process of doing things here. So there's just a fairly typical one. If we send a message that's an alert, so it's a breach essentially. So when in this particular case, the air quality goes above a certain value, we simply just grab that message and output it to Slack. So The purpose here really is just to show what can be done. This is not necessarily the right way of doing things. You'd output this probably some kind of operational dashboard, probably, or depending on how you wanted to react to the air quality breach, you may raise an alert on some kind of messaging service. So again, if you just one final one, because it's slightly different. So we'll look at the reset device. So what this one is doing is this is essentially an HTTP endpoint, and it's calling an Azure function. And the thing that it's passing into the Azure function, if we look at our code view, the thing that's passing into the Azure function is something from the inbound form data. So why is it doing that? It's because if we essentially, what I've done is I've configured a slash command inside Slack, which is this one here, a slash command, so that when I type slash reset device and a piece of text, it will post it to that endpoint. That piece of text will be taken out. By default, Slack sends a message in a form encrypted format, and the text after the slash device is added to a field called text. So that's why we use that. And essentially what it will do is it will then grab that as it runs through here, and it calls an Azure function. The Azure function is pretty straightforward. We'll just go here. Here's our Azure function. So we read the device ID, and then we connect to the IoT Hub. So this is using the service client as opposed to the device client, because this is a back-end process. And then we invoke the direct method. That direct method that we invoke is called reset device, which of course is what we have in our code. So what's that going to do? That is going to call the service endpoint inside IoT Hub for that particular device, and it's going to invoke the reset device method. IoT Hub will then call that device method on, or that direct method on the device. Now, the thing to remember about device direct methods is that they are synchronous, so the device has to be connected because it's essentially an ACK kind of process. So invoke that method, and hopefully everything will work. And the last part here is that we'll talk about just now, I guess, is to do with stream analytics. I'm not doing any Databricks in this particular solution. Excuse me. So in here, we can go in and we can add inputs. So again, this is all very, very useful stuff in terms of an integration space. So remember, I mentioned that we can have inputs of Event Hub, IoT Hub, and blob storage. And if we just go and have a look at our outputs, we've added Cosmos DB, but we can add a bunch of stuff here, and you can see there's a great deal of things that we can invoke here in terms of outbound. Now, right now this isn't started, so let me just start this. I did that because I wanted to show you the inputs and outputs, and you can't do that when it's started. All we're doing here is we're saying in our query, everything that's on the inbound in IoT Hub is going to go to Cosmos DB. And the key thing to think about here is that if you remember, we had that message routing. Remember, the message routing happens before it lands into at the event endpoint. So if things don't match any of those message routes, they'll just land at the endpoint. So we essentially take all our alert data and our status data out of that inbound telemetry, and only the actual data telemetry that we care about comes through to this particular stream analytics job. So I'll just kick that off. That just takes a couple of seconds to start up. And whilst that's starting up, we'll just have a very quick look at what that looks like inside Cosmos DB. So in Cosmos DB, we land our status information. So we have a battery level, a device ID, and a firmware version. And if we just go quickly back into our code, we can see that here: device ID, time, firmware, and battery level. So there's our time. And then a bunch of stuff that is very specific to Cosmos DB. And we also land in telemetry in here. So we'll just have a quick look at what one of those looks like whilst Stream Analytics is starting up. And you can see we send through the device ID, time, the temperature that we've measured, humidity, air quality, and a bunch of other things that are specific to both IoT Hub. So here we have some IoT Hub level information and Stream Analytics information. Oh, sorry, Cosmos DB information. Excuse me. So hopefully we have started now. Okay, that looks like it might still be starting. Did I click start? It's not actually essential to the demo. This hasn't started. It can take a few minutes to start. Your job is running. Fantastic. Right, so if we kick off our code, here we go. So it's sending some information. It's updated the status. It's uploaded the file, and there's our status command. So if we look at that battery level of 73, and it's sending some telemetry as well. And we can see as we're looking at this telemetry, 350, 50, 25, that data isn't changing because if you remember, the device twin had it set so that it wasn't going to vary the data. So if we just go back into IoT Hub and look at device 1, excuse me. Device 1. We can see here that my battery level has changed. That was 95 before. So the inbound telemetry as part of the device twin is working. If we change this to true, spell it correctly, and then save that, what we should see over here is the data is now starting to vary. So essentially what we've done is we've pushed that data back down. And remember, I could have done this as a result of any back-end process updating the device twin. I just chose to do it through the portal for ease, but there could have been a process which did that. We're just waiting to see one of these breach out in some way, so it doesn't usually take very long. So we can see here that the air quality is breached, so it's now static. And if we go into our Slack channel here, we can go into air quality alerts and we can see we're getting breaches. We also get device events. So what I also did, and I didn't actually mention this, is there's an opportunity to take the device events, so connected and disconnected events and device created and device deleted events inside the operational monitoring endpoint and send those out to somewhere else as well. So that's just a very simple logic app that just pushes out the fact that this particular device is now connected. We can see here that, as I say, air quality is still breaching. So we can see here, yeah, it's not looking terribly happy. If I go into general here and I use my / command, this hopefully does work. Device 1, I issue that. So that's because it's the function has spun down, but that's just the return part. So the function has basically spun down. So now the reset was actually started. But if I call that again, it should just work as the function would have started. So there you go, device reset. And you can see reset device was called, and it's back now to, or it did go back down to its original values. So nothing was breached, and now it's going back up again because remember, vary is still set. So I haven't set vary to anything. So to anything false. So you can see that's all the communication channels really tested out there. We were able to set some data, and now we're getting temperature breaches as well. But we were able to set some data to make it vary through the device twin. We're sending data up through a message to the device twin as well for the status. We're routing data. You can see that the route is occurring here. It's routing the data through to Slack. So we could obviously, if we needed to, we could push that out to a messaging service if it was important, or if this was you going through some analytical tool for predictive maintenance, we could log a ticket in something like field services to make sure that something was repaired. And there's a great case story around ThyssenKrupp around them doing that exact story around knowing when their lifts need repairing or need maintenance. And likewise, we were able to go into Slack and send a message directly back to IoT Hub to enact a change actually at the device level as well. And that went through Logic Apps. So we've been able to actually check and test all of these parts. which is quite good, and it's again pretty low code, low and no code in a lot of cases, and just using the integration tool set that you're very, very used to anyway. So with that, I think I've probably got about 10 or 15 minutes left. I think we'll probably finish a little bit early, so that's good. So if there's any questions, let's go back to the slide deck. So that's the demo. Hopefully that was useful. And like I said, the key part there really is just showing that all those integration paths, whether that's message routing or anything else, are easily exercisable through the standard set of tooling that you would use every single day of the week. So what does that basically mean? Essentially, that means that everybody gets a chance to do integration. So whether it's data integration, whether it's standard integration that a lot of people would normally do through Service Bus, through Event Hub, through functions, through logic apps, all those tools are exactly the same tool set as you would normally use. But really, actually, I mean, the key point is that IoT is not about the hardware. It actually pervades all aspects of the application stack, and that's true not just of integration. That's true of web development. That's true of BI reporting. That's true of data and analytics and machine learning and AI. That's true of robotics and machine-to-machine integration. That's true to field services and maintenance stuff. So the key thing really is it's about that processing as much as it's about sensors, and it's about the outcomes based on that data processing as it is about the sensors and everything else. And the key point really is that you can't do any of this without the integration tool set that we all know and love, and the Azure Integration Services enable that full end-to-end solution in IoT in a fairly low code or no code, and certainly a serverless way that helps us make solutions that are practical, lowish cost, and manageable. So what does that mean in the grand scheme of things? What that means in the grand scheme of things is that you can still be the integration superhero that you have always been. I apologize the fact that these are DC characters. This was at Warner Brothers on the Gold Coast, and they didn't have any Marvel characters, unfortunately. So apologies for that. So with that, I'll close out, I think. So that's just my details again. So that's at Martin Abbott is my Twitter handle. Please reach out, and if you've got any questions, I'll follow back, and we can DM and chat about anything that you have. And with that, I'll open it up to any questions that we have.
Okay, so thank you, Martin, for that presentation.